To work with the Golden Gate assembly strategy on TeselaGen's platform, go to the Designs option on the upper menu and select Blank Design on the New Design option of the library view. Let's name this design Small DNA Library and add a customized description. Now, click on Save to open the design view. Here, we can see a blank design with 2 default bins. Let's add 4 more bins. Notice that, when clicking on a bin, it is possible to change its icon. To change the icon of a bin, just click on it on the right panel and select from the available list. Now, it's time to name our bins. To do that, we need to click on a bin and change its name on the right panel. Notice that you can see details of each bin by either opening the right panel or right-clicking on it. Once all our bins have names, we are going to associate DNA parts with them. To do it, double-click on the empty spaces under each bin. This will display a list of your available parts, where you can select one or more, and use the search icon to easily locate them. In this case, since we are working with a combinatorial design, we can add more rows to add variants of parts for each bin and continue with the process. Notice that if you duplicate any of the parts, the software will let you know by adding a yellow line on the parts that contain the same sequence. If it was selected by mistake, you can remove it by selecting the option when right-clicking. Next, we are going to click on the SSRA_5 prime tag parts, select Embed in Primer Reverse from the Forced Assembly Strategy list on the right panel, and repeat the same process for the SSRA_3 prime tag part, selecting Embed in Primer Forward this time. Notice that this time, instead of the right panel, we right-clicked and selected the option from the list. The software will show a small colored square indicating the assembly strategy for those parts, which you can easily check by positioning the cursor over them. If you don't want to consider direct synthesis for a part, you can impose a direct synthesis firewall on it by either selecting the option on the right panel or right-clicking on it and selecting from the list. This will be indicated on the design with a red stripe on the right side of the part. Now our design is almost ready. To finish it, click on the backbone part, go to the Assembly Reaction Details option on the right panel, and select the assembly method to be used. In this case, we are selecting the Golden Gate assembly and choosing our restriction enzyme. Now our design is ready, but there are still more things to do. TeselaGen software offers a powerful analysis tool for our assemblies. To use it, click on the Submit for Assembly option in the upper right corner of the screen. This will automatically send our design for its analysis, creating a new task. We can check the status of the task on the Notifications or the Tasks section of the upper menu. Once our report is complete, we can check it and find the next sections. Pre-built constructs. These include the desired sequences that were already built and are available on the physical inventory. Constructs. Final desired sequences to be built using the design analysis. Input sequences. Obtained from the input parts. Input parts used in the analysis. Assembly oligos that need to be synthesized. Annealed oligos. Digest linearized fragments that are going to be used in the assembly reaction. Synthin sequences. Includes the sequences that need to be directly synthesized. PCRs need to be run to generate the assembly pieces. Assembly pieces of DNA that will be in the final assembly reaction. Assemblies. Includes assembly pieces that need to be combined to create each construct. Some parts generated like oligos, constructs, or assembly pieces can now be part of your libraries. By clicking on any of the parts, you can obtain more detailed information about it and see it on the Open Vector Editor. Remember that, since these parts are related to a design, they can't be edited, but you can duplicate them to have a copy to make changes on. Keep using TeselaGen software to optimize your design process. Learn more with our learning resources.